Okay, yeah, just getting started here. I'm just checking audio levels, seeing if everything's good. If there's any issues, let me know. I got the camera going now. Yeah, just getting stuff ready. One thing to note is it was a suggestion to move the chat. This is not an ideal scenario. I do want to like work on this a little bit more. Trying to find like the ideal way to integrate a chat into a text-heavy stream like this is a little difficult, I find. So, but yeah, I did move it from the bottom to over here on the side, where mostly we're not doing anything. So I'm just playing around a little bit with giving a little bit of space. But yeah, about to get started here. Before we do that, I'm just go ahead and paste in our GitHub project. It's kind of hard to read with that purple, but there it is. Yeah, purple makes it hard. And for people who have not joined our Discord group, I'm going to go ahead and link that for anybody who wants to participate in chatting about Zig or fighting games or, mostly generally game development kind of things. Where is that at? Where's the invite? Oh, there's invite. Okay. Let me go ahead and just invite everyone there. And also just a way to test out the chat. Purple links are hard to see on this, apparently. I'll keep that in mind. Maybe I need a lighter color. Let's change that just a little bit to a lighter color. Or maybe I need a dark theme for my chat. Let's go ahead and lock these so I don't do anything with that. Everybody can hear me just fine, right? That's shouldn't be an issue, I assume. Let's see. Color source. Make it a little bit lighter. Will that make the purple links easier to read? Only somewhat. Anyway, it's a little distracting. It doesn't really blend in that well. I don't know. I don't know the ideal way of doing this. We could turn off the color. But yeah, then like when I'm looking at I wish I could just put just a blank thing here. Unfortunately, it collapses that way. So I don't know. I don't know what's ideal on this. I'm not a great Twitter, as you might put it. But yeah, okay. How many people got in here now? Do I even get an accurate number from OBS? Do I have to actually look in the thingy majig chat room? Actually, I'll be right back. I need to get some water so I don't get the old dry mouth. Okay, I think we get started here. Sorry I wasn't able to stream last week. Just very busy with work, but this week hopefully a little easier. Yeah, just to cover what we did last time, just looking at what we had on our agenda, we're going to attempt to write the game's character data from and to a JSON file, which we only partially did. We got writing working. We're going to make a test character and write to a file, load a character data from file prepared and ahead of time and validate his data. Yeah, so I'm going to move this to today. We're going to be able to read a JSON file that is going to describe our character data, including actions, hitboxes, things like that, or at least events that happen during an action, aka a move, things, yeah, like collision areas, just basically hitboxes, sounds, other properties, things like that. Pretty much everything you want for character. Ultimately, I think we're going to split it up into multiple files, maybe one per move or something like that. But for now, it's going to be one file. Okay, let's see. Yeah, so the main thing is write a deserializer write a deserializer that walks that decodes the JSON object. So basically, the JSON object is going to be something that Zig generates using its own library. That's just basically a tree of values, and we have to like walk that tree and convert it back into our data structure within Zig. But before we get to that, just to go back to see what we did last week, or a week before that, sorry, it's been a while. So we had this test parsing of a JSON file that's completely, I'm just getting rid of, or I'm just going to comment that out. So we had this like writing to a file test, not a real true test that actually validates what it wrote, but it just kind of shows us what gets written out. So, you know, if we run test source, character data, whoops, Zig test source, character, it should pass, well not pass, but at least write out a file. So it wrote out this file right here, which we can see within our project. Where is it? Not docs. It's under source. No, hold on. Where did it write it out to actually? Oh, there it is. Yeah, so this is in our main folder. Yeah, okay. So yeah, it wrote out the JSON structure. So we want to decode this now into, well, deserialize it back into a JSON structure, Zig structure, sorry, from JSON to Zig, effectively. Okay, and if you look at what we did last week, the main thing was, so we learned to create a file, and then we stringify using JSON, the built-in library for stringifying. The problem was we use array lists, which are a dynamically resizable array, but the built-in library doesn't support just reading and writing those directly from a JSON array. So what we had to do is implement our own handler for our structure, which is what ends up being called by the library, the JSON library. And we just basically created an anonymous structure, and instead of trying to serialize the array list directly, we effectively got the slice, stored that in the structure, and then used that to stringify. So it just came out as a normal array. The problem now is because the JSON library doesn't support just reading an array to an array list as any kind of option, we need to do that ourselves. There doesn't seem to be the reader version of this. This is the like writer version of a custom structure handler for serialization. So what we're gonna have to do is actually use something called, let's get to it. I actually wrote a prototype for this ahead of time just to learn. So we need to use the, where is it at? It's part of the JSON library. So what we do is tokenize the stream, which creates a, just basically effectively a list of tokens, and we pass that into this thing called, where is that at? Yeah, where is that at? Is this the right? Oh, that's the wrong file actually, sorry. Give me a second. Yeah, here it is. So that's not what we do. So we have to create a JSON parser. So if a P, it's parser. This is part of the library, this JSON parser thing. It is an object that basically will store or give us a tree of values. And we can walk that tree to convert each value back into part of the Zig structure that we're using. So basically, I created a prototype JSON file to walk. It's just a simple kind of structure that has an image with width and height, a bunch of like texture indices and tiles, things like that. And I just use this to kind of learn how to use Zig's reflection system to actually walk the tree. The idea is we're actually going to walk the tree of embedded structure, so structs within structs, so that we know what values to actually read from the JSON object. The way I did that was just a quick little code review. So I made this function parse asset. You pass in the type, which is an image. As you can see here, it is just width, height, textures, and tiles. And as you see, there are array lists inside of here, which they themselves are structs. So, sorry, I think the yeah, the array list are, so we got an int, and then we have a tile, and the tile itself is a struct. So just demonstrating that we can deserialize a array list of primitive values and our custom type, a tile. Okay, so just to show what I did here, we'll get back to it. Effectively, I'm just using debugging here to see what happens. So let me show you. I did debug print, and I should have like a test file here. Where are we at? Yeah, image test. So image test is back here again. So this is the file. So if we run test on, I think I did this here. So we effectively able to walk it. And I'm just like printing out what kind of thing it is. So we read the width and height here. We got to the struct textures. Sorry, this is a struct because it is a array list is a structure. And it realizes that it is an array. It walks it, prints out all the values. You can see 0, 5, 6, 7, 8. It's printed here for each indice. It gets the tiles. It realizes that it is an array. And it's an array full of structs. It's an array list. And for each one, we realize that it's an object in JSON and a struct in Zig. And we print out the values. You see here 3, 20, 10, 60, 600, 800, 33. This is the same for this. So we're able to parse that file like that. And I'm just going to walk through this code a little bit before we rewrite it for our own purposes. The thing is, what I've not done is actually the part where we convert it to a Zig structure or an instance of the Zig structure. I'm only, since it was a test, I was only trying to learn how to use the reflection stuff in Zig, the comp time stuff as well. So I just used debug print. Okay, so the main points here is we pass in a type, which we know at compile time. So this function will be run during runtime, but the type will be known at compile time. So this value will be at compile time, which is the type, and then the tree of JSON values is something that will be a runtime value. Okay, so the first thing to do was we switched the tree just to see what's in there for debugging purposes, and it's an array, it's an object integer. These are all, this is a union, a tagged union, so it gives us, depending on what kind of value it is in the JSON, original JSON, and this is just kind of just to know what that value is that we're passing in. Okay, and that was just for a test. We won't need this part for our actual game code. Okay, and what I end up doing is calling this type info command in Zig. It gives us a structure, built-in type info structure, which gives us information about the type. So, and you can switch on this. It's a tagged union. So, if it's an integer, I just print out the integer value. If it's a struct, I want to see whether or not it's an array list or is it a any other structure. For now, in the future, we're going to probably support hash maps. So that'll be something we'll have to add later. So I made a function isArrayList. I need to know whether or not this is an array list at compile time because the type info is coming at compile time. I'm walking the hierarchy of the structure and array list and structures at compile time and generating code that can parse the JSON file or deserialize the JSON file. It is that's the kind of general strategy here. Is so we know the type info, we can walk the hierarchy, we generate code. The generate code, the walking the hierarchy happens at compile time, not runtime. That does save us obviously the overhead if we had runtime type info, which Zig doesn't have. I don't know about that. I'm pretty sure it doesn't. So again, that happens at compile time. So I need to get the value of this at compile time. That's why it's comp time var and not just const array list equals array list. So this function is array list. We had somebody help us the other day on that, help me about that. It was, yeah, Marler, very, very helpful. Thank you, Marler, 8997. I will just show his example code here just as a starting point. It was incredibly helpful to make progress on this. So he made a function called isArrayList, passing a comp time type. Switching the type info, if it's a struct, it just assumes it's fine, and otherwise it returns null if it's not a struct, because array list has to be a struct. Just to check, the strategy was to check to see if it had the filled items, because all array lists have items. Well, it is part of the definition of array list. So that's something we can do at Zig at compile time. We can pass in a string to this. I'm just called a command. I forgot what these are actually called. Built-in function. So the built-in function. So what the strategy was to make an instance of the type, right? If we know it has doesn't have items, then we can return null here. And you would get the type of the list of items within that T array, right? And what he did was switch on the items. If it was a pointer, what do you do? He would compare if the child type, if this newly generated, because this basically generates a new type, right? Using the child, if it was equal to the type we passed in, then what we could do is, sorry, what does it do here? So it would return the info. This is a little bit tricky if you're not used to Zig, but it's like returning either, giving this condition, the child type or null. So we would get back the type or an optional type, so either null or the type. So, and he made a little test here to see if it's I don't know exactly this, but anyway, yeah, he does a test here. If the type within is 30. So I did something similar, not exactly the same. Hey, what's up, Christoph? IT. Thanks for dropping by. So what I did was a little different. It's very much simpler. So it's just basically, it's going to be good enough for now. Obviously, we're going to have to do something more rigorous later. What I ended up doing was just switching on the type info. If it had the filled items, just return whether or not it had the filled items if it's a struct, right? That just means we're assuming anything with items is going to be an array list for now. Otherwise, return false. I just did this here because Zig needs, if you don't exhaustively cover all the possible elements, fields of the tag union, which this is, it will just return an error. So anyway, getting back to that. So at comp time, we know if it's an array list or not, again, because we're testing the type. In the case where it's an array list, what we do is we walk through the, so this is executed at runtime. So at runtime, we'll walk through the list of items in the JSON value tree, because we know it's an array. Sorry, give me a second. So we'll walk through the array, and we'll pull in the item and the index. Index here we're just using for debug purposes at the moment, but and the item could either be a basic value, or or primitive value like an integer, bool, string. Well, string is not a basic value, but anyway, we recursively call parse asset, which is this function, and we just do the whole thing over again. So that's for arrays. In the case when it's not an array list, it's still a structure, but not, sorry. Yeah, still a structure, but not an array list. We assume it's just a plain structure with fields. So we switch on that. We can get this, we got the struct info up here because it's a tag union, so the union has the fields that we need. So yeah, we walk through all the fields in the structure. This inline for, it will unroll at compile time all the fields because we know the type info. So this all happens at compile time. And then at runtime, we get the value of the object, assuming the field name is the same. right? We want to get the field in that JSON object. We want to get the field that matches the field in the structure. And we'll switch on that field type, which again, this is unrolled during compile time. And so in the case of integer, we just print out an integer. In the case of struct, we're going to recursively parse that struct for each field type. And that's pretty much it. And then all we have to do is call it on our type and then on the value we've gotten from JSON. The only reason I don't think I had to do this. I think I could have used the root object, because JSON has a root object where technically image is just one field, or at least in this case, when it was parsed out through Zig's library, stringify library, it did make image its own field. If there's a way to change that, I think it's possible, but for now we're just going to stick with this. Hey, Christoph. Yeah, I'm really loving the comp time stuff. It was a little tricky coming from templates, not being able to kind of pattern match type and subtype stuff, but getting the hang of it using the other tools that are provided to you, like checking to see which fields and stuff it has. I think that's a very straightforward way of handling it, like checking items, whether or not it has to field items and stuff like that. It's not rigorous enough to make generic code in the sense of like, oh, you can plug anything into it, but it is great for, I think, for this kind of game stuff where we know what our limits are, right? What our restrictions are going to be. We know what the input's going to be. It's very curated. Okay, so yeah, we have this code, right? So what I'm going to do is, how do I make it? Can I make another? Yeah, okay. So I'm going to pop that over there. We're going to go open. How are we doing on time here? I think I'll walk the explanation. And it didn't take too long, I think. Okay. So going to go to our game simulation. We want to go to our, where are we at? I'm going to go to our game data. So because we have our parsing code here. So I'm just going to copy over some of this code. There's no shame in that. And go up here where before our tests start, I'm going to copy over just, did I use this function? Oh, I didn't cover isItem type. It's just, yeah, this just gives us the type within the array list. I just split that out pretty much what our friend here did. He made it as one function. I made it as a two. But yeah. So here we are. I'm going to pull this down. I'm going to put both of these in here because it's the utility functions we can use. Okay. Anyway, so we're going to start with parse asset. I wish I had more screen space, but it is what it is. Okay, so we're just basically going to start from the beginning, walk through each piece, test each bit by bit. Let me see. Oh, honestly, maybe the better strategy is just to copy and erase the stuff we don't need, right? And then we'll just get it all working from there. Okay. So we're going to change the name from parse asset to just parse JSON. Oops. I'm going to change. It's not really parsing. It's I don't know. Naming is hard. Naming is hard. So I'm just going to call it parse JSON object for now. Or maybe better to say parse JSON value. Okay, because it is a value. And we have this debug stuff in. I'm just going to get rid of this. So let's just think of the base case. A lot of the time when I'm doing it kind of recursive algorithm, I want to think about the base case first. The recursive part is just kind of given, right? You walk through all the items and call this function recursively. So think about the base case. What if the thing is a structure? It's either a structure or an int. Well, a structure, you'd go through all the fields. In the case of integer, oh, by the way, right now we're just going to support, we're going to have to support strings, integers, and of course structs, arrays. I did not support strings in that prototype. Hopefully it should be pretty straightforward, but we'll get to that when we need to. Okay, just starting the integer case. So right now we just wrote, we just print out, do a debug print. We actually need to store this value somewhere, right? So just starting with, whoops, what's happening there? What is visuals? I don't want that. Anyway, yeah. So we're going to basically have to store it within the Zig structure itself that has that field, right? But we're recursively calling this function. So one strategy is we'd have to pass in the pointer to that field and copy the value into that field. That's one way we can handle it. The other way is to return the value to the thing that just called it. So the thing that is calling it can set the value of that field. In that case, it's like, because the top level is walking through the structs fields, you would walk through it. If give me a second. So right now, we actually have so now I'm realizing we have integer check in two places. So we could, instead of calling it, we could either call, this one thing we could do, we could either call it and get the return value in the case of int or a string or whatever, and just assign the, so let's think about the other way around now. Sorry. So we know what structure we have, right? So we're going to get to actually storing this off in the game's runtime memory, but for now we'll just make it a local variable. So we'll say var I don't know, instance of struct, and we'll rename stuff later again. Yeah, so we know the type. The type is t, right? Because we pass it in. So we know it's a structure, so we can say equals the default values. Right? And this is just a sketch for now. We can get more into it in a bit. And the idea is we're going to take the instance, and in the case, say, if we do it this way, if it's an int, the field's an int, what we need to do is get the field. So we need a way to get the field of this instance. And I believe there is a command for that. It's like get field or something like that. Field. So performs field access by compile time string. Works on both fields and declarations. So is this the best way to do it? We pass in the struct and get the string. So we could do it this way, I guess. We could pass in field, the instance of struct, and then from the field info, what is? It's not great at getting the autocomplete here, but we can do though zig type info, and I think it gives us the right GitHub link. Hold on. I think that's the right place I'm going to go to. usually I'll get, anyway, I'm just going to go to the Zig repository. That just makes things easier. The lib. It should be built in. Yeah, so there should be in the tag union there is a, whoops, is this right? Struct equals this. So fields, then we have a struct field. It's just name for the, so that's just a const unsigned byte. So the field should have name, and that's going to be equal to the value.integer, right? So that's one way we can do it. We're going to leave the debugging for now. We're trying to parse a JSON array into an array list. Is that why you're implementing a metaprogramming stuff directly and stuff? Yes, exactly what I'm doing, because it can't. We're going to parse into array lists and not into a plain array. The reason for that is kind of like if it was runtime only data, we could use as a plain array because it's not going to change size during the gameplay. But we're going to have eventually built-in editing of these properties as we're building the game. So we're going to have some dynamically resizable array. And one option would have been to have 2 different data structures for our game data for each object or each type or each asset. But I just decided to stick with array list instead of having a runtime versus a edit time type. In the future, we might change that, like having a compiled version of the asset, a cooked version of the asset that's more performant. But yeah, this is kind of the way we kind of iterated into. That's why I'm doing the metaprogramming stuff. Also, it's also useful. I wanted to learn the comp time stuff in the first place, and this was just an opportunity to do that. Okay, so we can close out this for now. We can get back to this. I'll go ahead and say that. And okay, yeah. So we're just going to assign the field. I think this works. We can assign the field the integer value here. So that works for the integer case. Now, for the case of a struct, well, of course, we need to call all things recursively. But still, we need a value, right? Again, the problem was we either have to pass in a pointer to the field we're going to assign, or we need to return the value. So here's the question. Since we're doing this, you know, comp time stuff, of course, we need to call, it's not parse asset, but parse JSON value, because that's what we're calling it now. I should have used the refactoring stuff. Do you have a refactor here? Yeah, rename symbol. But so right now I'm returning void, but I could just return a value. It would have to be optional, so it's going to either be null or what would I use here? Any type. So when it generates this function at comp time, does this work? I can't just do optional any type. Okay, I'm still learning on this stuff, so that was going to be my assumption. How do I return? Oh, I'm an idiot. It doesn't mean the any type. It just needs to be T, right? Yeah, so Christoph, if you were here last time, we actually did implement our own version of JSON stringify effectively to generate a anonymous struct that instead of, you know, using the array list directly, we pass in the items field. Yeah. I'm going to jump back in the future. I'm going to come back to this instead of using this method. This works for now, but I think I'll do some metaprogramming again to generate the because it's kind of annoying to implement this for every struct. As you can see here, we have this for this struct and this for this struct. Instead of doing that, I'm just going to basically do some kind of metaprogramming, so I don't have to do that for every struct effectively. Yeah. This was a suggestion we had last time from other Zig programmers who were in the chat, so it's not, you know, something that I was familiar with. let's see. Okay. Yeah, just jumping back here. So we should be able to pass optional type back. Does it need to be optional? Well, for now, let's not make it optional. Well, the problem is we do have an else, so we do need to have an optional, right? So, so the return null at the end here, and this is, this is return the value. In this case, so for the integer case, return. Oops, yeah, we return the value. Again, this is like a tagged union, so you can just get the type, I think. You get the value directly like this. Okay, and in the case of structs, right, we would do not value.integer in this case. We'd call it recursively. Parsation value. Well, do we even need to do that? It's kind of... I'm trying to think a little bit about this. Well, let's just say we technically don't even need to do this, right? We don't even need to know that it's an integer necessarily. Here, we can just do, instead of doing struct, it's either a struct or it's just a plain old value. It's either an integer, string, whatnot. We could do something like, I think we could just do this and pass in the value, get rid of this whole thing. What does it hate here? Oh, we don't need this anymore. And then once we call it recursively, we end up getting an integer. We'll print that out as integer. Cool. So that's the base case handled, right? In the case of structures, we're going to call it recursively. Oh, so we don't even need to have wait. Let's be careful here. Thinking about this because we're talking about complex data structures. Things need to be copied into dynamic memory. We have we have array lists. So this is what the problem is. You get in the habit of programming language like C++, where it's like, okay, I'll just return the value, and it's just going to copy it. But we're talking about array lists here. It's just too naive to do something like this, right? Where I don't even need to have a switch. What I'm thinking here is I don't even need to have a switch here on the type. I can just do something like this, right? And get rid of this entirely. And then the base cases are all handled by this switch. So when you recursively call it, it's either in a structure. If it's an array list, it loops through here. If it's a struct, we get through all the fields, and we just recursively call it with the value. And assign the instance we just made here, each field name. I still need to learn more things about array lists and how it gets handled. Well, let's just be a little naive because sometimes instead of getting stuck, it's important. Sometimes it's okay to like try stuff when you don't know anything and see what happens. No, I'm just thinking about copying memory around, right? Like I don't want to just copy pointers that are not managed. What's going on here? Oh yeah. But anyway, I don't know. So okay. we'll do something like that that handles the struct case. Now we need to handle the array list case, right? So we're gonna go through all the items, we're gonna parse the value, and we're gonna do the same kind of thing. But we're not gonna do instance of struct. What we need to do is we need to make a new array list. So we're gonna need an allocator. Now that I realize this, we need to pass an allocator for the array list. We'll get to that. Since we have an array list, we do need an allocator. Let's get rid of the debug information for now. So we're going to have to make a new array. Let's say instance of array. It's going to be have the array list of type. What is the type? Oh, it's item type. We just got that here, right? Oh, it can't be that. It's got to be standard. Sorry, standard array list, right? So we don't have this here. We need to be outside the loop. And then, well, we need an allocator, right? Yeah, so we're gonna have to need an allocator to add each. So we're gonna have to do something like var item equals this, and then like instance of array list dot. Is it append? Yeah, append. We need append. Oops, we named item twice. Item value. Use item value, and then we need to append the item with an allocator. We don't have an allocator yet. Okay, we have no allocator at this moment, but we need to add one. So we'll have to do this. What is standard? What is it? Standard mem. The allocator is what it is. Allocator. You are correct on that, I believe. Yeah. Yeah. Yeah, we don't even need to do that. That's correct. We should be just, we're given the type. You're right. So do we still need to do, I always forget about this. Give me a second. Yeah, we need to do an init, right? We need to do an init. So just give me my brain working here. Does that work? Oh, we need to pass in the allocator, right? Sorry, just reviewing stuff real quick. Okay. So this gives us a, sorry, just circling back. So we create an instance of the array list using the type passed in. Thank you very much, Christoph. You're much helpful. Yeah, you're correct. My brain is. Yes. So I don't think we need that anymore, right? Yeah, my stack is full now, so things do overflow. I don't even notice them. I get very much focused on what I'm doing right now, and I forget about what I was doing previously. But this is probably a better way to do it, is make an instance using the allocator that was passed in. And then we have the instance. We're going to append the item that we just got from the JSON object. Yeah, I mean, I did this kind of stuff in C++. It is a nightmare in C++, man. You don't even have real reflection in C++, so yeah. Yeah. Okay, so just reviewing back, I'm gonna get rid of this debug information to clean things up. So the base case of handling an integer. We get through the array list, and we need to return the array list, right? Okay. We generate the array list and we return it. In the case of other structures, we make an instance of the struct. We go through all the fields, get the value for that field, and pass it in. Okay, so now we need an allocator. We can just pass an allocator recursively here. And let's just see if it compiles real quick. What is it zig build? I forget. No, I don't even have to do that. Let's go. We don't have any tests yet, so we'll have to start writing tests here in a second. I just want to see if it builds. Yeah. Oh, right. That's why I had it. Yeah, thank you, Christoph. I'm just looking back between the chat and the thing, so I'm just missing things. 36. What is going on here? Oh. I need to look at, I need to move the chat closer to me so I notice once update. Oh. We don't need this anymore. The capture is not needed. Sometimes I just like to compile and to catch my errors like that. Oh. Sorry. Almost instead of, okay. You're correct. You are absolutely correct. I gotta get used to all this stuff, man. My muscle memory, visual muscle memory needs to be trained to see these problems. Okay. Now remember, named hitbox group instruct game simulating game data. So that's another problem that we need to fix, but that's fine. So we're just going to run the test in this file to see if any kind of syntax error happens real quick. Data, okay. Okay, so existing test pass. Now we can start on our new test. Okay. So let's get rid of this. I don't need this part. So let's say, so just test reading a JSON asset file. We're going to change these tests in the future to be something more that we use for debugging our code. But for now, we will open the file and stuff. So let's go back to our reflection file. Where is it? It should be under prototypes. Okay. So I'm just going to like kind of steal this from my own code real quick. Yeah, so we're probably going to move this stuff into a higher level function to abstract it away some, but I just want to write the test for now, and then we'll get to there, just to test the other code. So let's just, where do we write our file? Okay, it's character test. So, oops. So we're going to open our character data test file. Okay. And again, this is just reading things into a buffer. We get the tree, and then it should be character data. What's it called? The top level is character data, right? Where's our file? Interesting. So it's not going to write out the name of. Oh, and we're fine. We're fine here. So we're good because we had custom structs, stringify function implementation. So we don't actually need to have that top level object name. Sorry, I'm thinking a lot to myself right now. So we don't actually need, I don't think we need something like this. We just need to do, so let's do, so we need to have, is this going to work? Yeah, it should work. So let's just say const, it's going to be equal to parse JSON value. We need character properties. We need a, what's going to say? Tree.root, I think that's going to be, end up being a value, yeah, tree.root. We don't need this anymore. And then we need an allocator. So did we, yeah, let's just use the testing allocator for now. That should be fine, right? Okay. So do we get any errors with that? Just a quick throw. Unused local constant, yes, that is an error in Zig. So we need to just ignore that for now. Okay, error, missing field, actions. When we make an instance, it needs actions. So we don't have a default for actions right now. That's a good point. So where were we at? Zig is amazing. Okay. So actions doesn't have a default value here. Is it okay? How would you do an array list? As it could be an optional array list, and then how do we want to handle this? So so we've done it like this before, right? Oh, we call it init. Okay, hold on a second. So we need to call init. Gotcha. Right. Give me a second here. So we've been trying to follow the not rule necessarily, but habit of having init functions for each of our structs that have resizable memory, resizable arrays. So when we create a new struct, we don't necessarily going to have an init function. So we could do metaprogramming to check to see if there's an init function or not, and then and call it. Wait, can we do that? Can we check to see if the function exists? I know there's a has field. You know, I'm just brainstorming. Anybody has a better idea if you know what I'm talking about? We're using struct initialization and not undefined. Do you have fields with default values that you don't expect to read? There is a chance there is values they don't expect to read. And honestly, I don't fully understand undefined, to be honest. The use of it. I'm still new to a lot of aspects of Zig. So, yeah, honestly, if you have a suggestion about that, you can let me know. Okay, so yeah, it's just a way to leave things undefined by default. But ultimately, we need to call, yeah. So, struct definition of character data properties. Okay, so basically, we just have right now we just have health and array list of actions. And when we init, we need to actually allocate the memory for that array list. That's what we call init. So you're saying it's legal to leave things undefined in the struct when you make an instance of it. I actually, it's something I was unaware of. Basically, we would start with a list, and then we can add actions to it later. So, right, it would not have a valid state. Yeah. So what I want to do is start with a character properties that does have an allocated what does have an initialized array list, and then so that we can add to it obviously later. So, you know, in our parsing code, we call init, right? We call init here on array list, so that's no problem. But we do need called init on structs that have an init function. Right, Christoph. So, so what I'm thinking here is on plain old. So right now we're making an instance like this. Instead of doing like that, we would change it to equals t.init and pass an allocator. But the thing is, we're going to have some structs that are just plain. Like hitboxes don't have an init function. It's just plain old data. So what I'm thinking is, sorry, what did I just do here? Let me just, yeah. What I'm thinking here, whoops. Because, you know, we had, you know, I want to call it an init function if it has an init function. If it doesn't have an init function, don't do that. And I was wondering if there's some built-in function that lets me check has, because it's has field, right? Oh, has declaration. Yeah, I think you should look at struct type info and set it to undefined, and see which fields have default value and assign those. So you'd only assign to fields that have default values. I think you mean that. So I guess what I'm talking about now, maybe we're talking about the same thing, and just I don't see the connection. But what I'm thinking about is structures that do need to have dynamic memory allocation, that need an allocator. So when we're parsing the unraveling the JSON tree, those structures that do need to have an allocator, I want to initialize with that allocator. Basically, that's what I'm thinking about right now. If that makes any sense. So my line of thinking is to see if it does have a function. So I don't know if that has declaration works for functions. It says declaration, so I was assuming maybe in general it supports it, but what I was thinking is like, oh, thank you, Christoph. You don't have to go so much out of your way, but for now, the sketch I was thinking of is like, I would have to make an instance first. That's right. I have to look this struct info. Going back to here, we have, oh, it has a list of declarations. Okay. So I have to make an so I have to do like dummy t equals undefined, and then it would have to be something like if has declaration dummy init. So I don't know if it includes function declarations or just variable declarations. So I would do something like, not dummy, I'll just do, yeah, I can just do this, right? If this has, then I could do this, right? I can do instance of struct. I'm so used to the C level way of thinking, man, on this stuff. So would be t.init allocator. That kind of thing. Else instance of struct equals default, right? Or whatever. That's what I was thinking. I don't know if this makes any sense. Yeah. Oh. Sorry. Has declaration is type, not a instance. Sorry, my brain is. Yeah, we have to do try, right? Oh, right. When we were, sorry. Gotcha. So instead of doing that, we would do if. I was going to say item because I don't really have a good name for that right now. So we need to unpack that optional, right? Because we're returning optional. Yeah, so we also 46. So here as well, we need to do instead of this, we do if. Expected 2 arguments, found 3. Hold on. Oh, we don't need to pass an allocator. Duh. Okay. Yeah. So this needs to be a try. Number 47. What's going on here? Expected. A list line, hitbox, null, found. Type info. What? Hold on. So we're only passing. This is where the meta-programming stuff gets out of hand for me personally. I'll be right back. Okay, let's overcome the Dark Souls boss that is this compile error. Try to unpack it. Okay, so we're getting an error union. So we're getting an error back when we're calling. I think the error is coming from the item is being it's actually an error union, right? It's trying to um append an error union, right? So I guess we're potentially getting error as a type when calling parse JSON function. Let me open that up real quick. So, I like this. Zigbin.io, is that a cool site? I'm just going to open that up real quick. That lets us copy paste. Huh. Is that a public site that is known for people to paste Zig code? Oh, and you can go to Compiler Explorer too. That's cool. Godbolt. Good old Godbolt. But yes, going back to where that was. I'm just going to just quickly go through here and see if I can understand. So we switch on the union, the struct info. You go through standard meta.fields. Huh, okay. You list through the fields that way. Get the default value. If there's a default value, you'll assign the field the value cast. Okay, as a fallback. Yeah, we'll keep that in mind for doing that. Oh, okay. Thank you, Renee Rockside. That is exactly what I needed. I knew it was something like that, but I wasn't entirely familiar enough to be able to give you the answer to that. Okay. I'm going to look at your solution again, Christoph, real quick, but I want to continue with this. Yeah. Sorry, just going through these errors one by one to see what it means. So, error is discarded. What? 275. What? Hold on, I'm just going to go to this one real quick. Yeah, 274 needs a try. Really? 274. Okay, it's just giving me the wrong line number. I was really kind of confused. Wait, is it like this? Is that where you need it, or is it the beginning? Oh, it's JSON stores as I64. Okay. That's interesting. Okay, so we need some kind of cast, right? Gotcha, Christoph. Okay. That makes sense. Let's where are we going at? Where is it? Oh, there it is. Sorry. Okay. Let's I need some kind of integer cast, right? Oh, I see. I'll get to the error thing in a second. Just int cast is fine. Int cast converts an integer to any other integer while keeping the same numerical value. Attempting to convert a number which is out of range of destination type results in a safety protected undefined behavior. YOLO. We start with the type, and then so 32. Well, you don't even need I32, just need a T here for now. Okay, so we need called try on here. Or am I insane? Putting tries all over the place, not knowing what the heck I'm doing. Attempt to use compile time variable at runtime. Oh. Whoops. Trying to use a compile time variable at runtime. Boy. What if I do? I'm just spitballing here. Doesn't change a thing. Okay. Yeah, which is the supposed content variable, right? Metaprogramming, man. Yeah, this is, I guess, well, this would be comp time, right? Just scroll down the list of notes. Right, okay, let's just, it's a lot. Is this, because it's recursive, right? So it's going to be, we're starting with the root, getting down to a field. So this should be part of the array list. The field is yes, field is comp time. I'm seeing it called from. Oh, called from. Oh, here we go. This is what you're talking about. Compile time variable assigned here. That is, okay. Got to read the notes. Why did this work in my prototype code, not here? So this is fine. This is fine, the fact that this is a comp time. Compile time variable assigned here. That's fine, right? Because this gets unrolled, right? The other notes. Reference versus reference, compile time variable. Yeah, I wonder if there's some way to work around this. Yeah, it's probably just a logical error on my part. That's what I'm gonna assume. I'm just missing something. I wonder if it's some weird combination of catching the error and assigning that. Because all this gets unraveled at compile time into whatever Zig's internal representation of this stuff is, and then actually compiled, right? So I don't know exactly what the generated code looks like. There's no way to like look at generated code, right? So it's it's hard to tell what's actually going on. Oh, it's a limitation of stage 1. Okay. The thing is, we could walk the tree, no problem. I was just debugging stuff, like just printing out what's in each value. But now that I'm actually trying to allocate memory, passing an allocator, I'm getting an issue. It's the try. Okay. Because now I'm using try, we're getting this issue. You cannot break return from inline for loops. Oh, okay. Gotcha. And actually, I just realized something. We're not returning anything here. I just realized that as well. We have the instance of the struct. We're not returning the instance at all. I don't know why you got an error about that. Well, I guess because we always get to null. But that is made me realize I did not return that. Yeah. So try returns on error. What should we do about this? This is getting the Ziglan in a way that I am not familiar with, unfortunately. So I'm trying to think about how to work through this problem. This is a point where I have to learn more about error handling and Zig before I can make any progress on this kind of thing. Okay, so instead of here, whoops, this is not where the error was, right? The error was, thing. So you can do like catch unreachable. Well, it compiled. We got a memory leak. Just because I didn't defer stuff. But it's probably fine. So, yes, we got an error leak, memory leak. We'll deal with that in a bit. But at least it compiles. That's one thing. So, instead of doing loaded character, now I want to try the reverse of this real quick. So, I just want to stringify real quick. Let's just do a block real quick. And I'm going to change all this code at a certain point, but yeah. I'm going to try to and then I'm going to try, can I do this? Debug, print. Just as like a quick sanity check. Oops. Yeah, we didn't need a character, we need a loaded character. Right. Oh, we don't need a buffer out, do we? Oh, that's for it. That's for the file. Unused local variable. My brain is what? Oh. Sorry. I'm getting tired at this point, so I'm going to start making more mistakes, so I'm going to have to apologize ahead of time. 286, so that should be string dot items. Is that gonna work? That's funny. Oh my god. Okay. Runtime value can be passed to code arc. You're right. I'm an idiot. I'm just gonna do this. It's gonna. Why even look at the sun? It's okay. So here's a sanity check. Does this look like what we read? Well, it doesn't have the brackets around it. That's for sure. But we don't really care about that, right? Oh, it does have the brackets. Hold on. Oops. Let's just do this as our quick sanity check. We've got a memory leak, and we'll investigate that in a bit. Not today, but it's okay. We can stringify it. It looks like what we read in, right? It looks correct. Let me load that file real quick. What file was it? Sorry. Character data test. That should be, where's open files? Okay. Now let's just put this over here. Look at it real quick. Compare it to our terminal. Oops, I'll just put it over here. I wish it was like a quick select diff kind of thing. Okay, well, looks right. Yeah, we got all that. Well, everyone, we made it. We at least we're reading in something. It looks correct for now. I'm sure we're gonna run into issues. We gotta deal with a memory leak down here, but that's just something we can learn, help us learn more about Zig and how to do that kind of stuff and how to handle memory management. So, but I think I'm gonna call it for the day. We're about an hour and a half in. I think it's a good point to stop. But yeah, big shout out to everybody on this in the chat, especially Christoph for getting us some of these over these humps on the Zig specific issues. And we'll come back. We'll continue later this week, hopefully. But yeah, if there's any other questions or anything you want to say or say hi or whatnot, feel free. Otherwise, I'll be shutting off the stream. Yeah, as always, thanks for dropping by. Appreciate everybody who's participated or just watched. And I'll upload the archive later today. I know it's late for people out in the U.S., so especially the East Coast. But yeah, definitely much appreciated for everyone who's come by. So yeah, until next time. Hope you have a good evening, good morning, wherever you may be. Yeah, very late, early in Europe, right? Like, it must be some crazy time there. But yeah, see you all soon. Enjoy the rest of your day, or good night. Till then, peace.